I cannot think of a single very tiny hurricane as like Patricia or Charlie back in 2004 that any of the computer models captured the change. So the ones that are more normal in size, if you will, and bigger, that the modeling of intensification seems to work a little better.
Bill Read, former director of the National Hurricane Center, believes we've come a very long way over the last 40 years of tropical storm and hurricane forecasting, but he also knows we have major advances that are still very much needed.
They certainly don't have the explicit physics they need, and they don't have the resolution down to the scale of the eye structure at all. It's mostly they're getting better at the overall structure of the hurricane, but not the details.
We've come a very long way indeed. Since 1970, when the National Hurricane Center began keeping records, the annual average storm track errors have decreased dramatically. In 1970, the 72-hour forecast average was 450 miles. That's like from Victoria to New Orleans. By 2015, that average had diminished to just 130 miles, like from here to Galveston, and the track errors continue to shrink. Here's why. The 1970s saw limited tropical data collection. A few islands, buoys, ships, and sporadic aircraft reports provided the only data. The quantum leap came with the launch of the GOES weather satellites in the early 1980s, which went beyond taking pretty pictures to delivering specific temperature, humidity, and wind data, where it was never available before.
Far more value to us meteorologists is the data that comes in from the satellites. Basically, 95% of the data that goes into our numerical models comes from remote sensing from satellite. Without it, we would be lost, and the next generation of satellites is going to increase that capability quite a bit.
So what are the major challenges to our forecasting capability?
Well, I think we still have some theory to crack. We're still working on some of the science that goes on in these eye wall structures that causes the changes in intensity.
How much better will our next generation forecast models be, and what is the timeline?
At the 10-year level, I think that's where we'll start seeing the research that's being done on intensification bear fruit.
NOAA is currently at the end of a 5-year funding plan that's transitioning them to enhanced data collection driven by launching the new high-powered GOES-R satellite system in 2017. In 2015, NOAA purchased one of the most powerful computers on Earth to accommodate the need for this level of data processing.
And hopefully we'll have come up with some remote sensing tools that will give us the data needed to initialize those models.